All right, we're going to expand what we have been talking about, applications with linear equations. Today we're going to look at finding a line to fit two data points. So if we want to find a line to fit two data points in a word problem, we're going to go through the process of how to do that. Some vocabulary for you to know. First of all, data. Data is just facts that are collected about a certain topic. So you will have facts collected. Statistics is the practice or science of collecting and analyzing numerical data in large quantities. The people who do this are called statisticians, and there are plenty of them out there with the stats of the day. Then a line of fit or prediction line is the equation y equals mx plus b that best fits the data that can be used to make predictions, because that's what a lot of things with statistics does. They collect data, they analyze it and see if there's a relationship between the data points, and then they use it to make a prediction for another data point that's not in their list. So we will be working on that in the next couple of lessons. So today we're just going to start with these. So we're going to go through the steps. I'm going to go through 4 examples. First, of course, we're going to read it. Novita noticed that she paid $125 after 3 visits to the gym. After 6 visits, she had paid $200. She wants to know how much she will have paid at the end of 1 year, or 12 months. All right, so she's going to visit the gym, and she's going to do 3 visits and pay $125 and 6 visits. And we're just going to change this last part. I want you to mark out the word months and put 12 visits, because we are just talking about not months, but visits. So we do want to change that to that. So we're going to identify what our X is going to represent, and I'm going to let that represent visits. How many visits she did. Then I'm going to identify what the Y represents, which would be the amount paid. Because the amount you pay in this problem depends on the visits. So visits has to be the independent variable, and the amount paid is visits has to be the independent variable, visits have to be the independent variable, and Y has to be the amount paid. So I'm going to write 2 ordered pairs. First of all, 3 visits, which is going to be my X value, is $125. 6 visits, though, is $200. And we want to know how much she would have paid at the end of 1 year, or for 12 visits. I'm going to mark this part out too. So how much she will have paid for 12 visits. So that's what we're looking for. All right, so first of all, we're going to find the slope. And from our last unit, remember that the slope is the rise over the run, or the change in Y over the change of the X's, and change has to do with subtraction. So on top, I'm going to take my 2 Y values, which are 125 and 200, and subtract them. I'm going to take my 2 X values on the bottom and subtract those. And that's going to give me negative 75 over negative 3. And if I divide those 2 numbers, I get 25. So I have found my slope. So I identified what the X would represent, what the Y would represent. I wrote the ordered pairs. I found the slope. So M is 25. Because if you don't remember from all our lessons before, we are looking to fill in y equals mx plus b. with M being our slope or our rate something changes, so it's $25 for each visit, and B is our starting value, which is what we're getting ready to find out. So we know that M is 25. So I'm going to put that up here. M is 25, and our two ordered pairs were 3, 125, and 6, 200. So from our last lesson, we learned how to find the y-intercept by plugging in, choosing one of these. I'm going to choose this one. The y value in that ordered pair is 125. The slope is 25. And the x value in that is a 3 plus the b. So we did these with two ordered pairs in the last unit. Now we're putting it into a word problem. So the 25 times 3 is 75. And then we're going to subtract 75. So B is 50. So that means that the place that she goes to must charge a starting fee of $50 because B is what you start with. And then we figured out M to be 25, so it's $25 a visit, $50 up front. We're going to make a prediction. Remember, we're going to do this. How much should she have paid at the end of 12 visits? And X was what we represented visits by. So we are going to replace X with 12. 25 times 12 is 300 plus the 50 is 350. So our prediction is that if she goes for 12 visits, she will end up paying $350. Now for example 2. A climber is on a hike. After 2 hours, he's at an altitude of 400 feet. After 6 hours, he's at an altitude of 700 feet. At what altitude will he be when he has hiked 8 hours? So what will the X represent? X often represents the time. So it's going to represent the hours because depending on the number of hours he's gone, then we know what his altitude is. Because the altitude is changing per hour. So hour is what's changing. So our ordered pairs, 2 hours, there was a altitude of 400. In 6 hours, there's an altitude of 700. First thing we need to do is find the slope. I'm going to subtract my two y values on top. And then I'm going to subtract my two x values on the bottom. It'll be negative 300 over negative 4, or 75. So this guy is basically climbing 75 feet each hour. So we found that the slope was 75. The ordered pairs were 2 400 and 6 700. And I'm going to choose to use this one to find my y-intercept, which will be what altitude he started at. So the y is 400, the m is 75, and the x is 2. 75 times 2 is 150. And so then I'm going to take the 150 away from each side. So the b value turns out to be 400 minus 150, which is 250. So that's the altitude he started at. So this climber is climbing 75 feet per hour, but started at an altitude of 250. Make a prediction. He's going to hike 8 hours. So remember, hours was the x value. So we have 75 times the 8 plus 250. So we're going to do 75 times 8. That's 600 plus the 250. So he'll be at 850 feet after 8 hours of hiking at the same pace. So he's climbing the mountain and getting higher and higher up. Started out at an altitude of 250. After 8 hours, he'll be at an altitude of 850 feet. So a teacher weighed 145 pounds in 1992 and 190 pounds in 2007. If she continues, what year will she weigh 202? Again, X is often represents the time, so that's going to be the year. And this is going to be the weight. So in 1992, the weight was 145. In 2007, the weight was 190. So to find the slope, I'm going to subtract my y's on top. I'm going to subtract my x's on bottom. So on top, it's going to be negative 45. And on bottom, it's going to be negative 15. So basically, this teacher is gaining 3 pounds a year. So again, it says if the trend continues. So what we're saying is if the teacher continues to gain weight at the same rate, what year will she weigh at 202 pounds? So the next step is to take our y-intercept and find our y-intercept. So our two ordered pairs was in 1992. She weighed 145. In 2007, weighed 190. M turned out to be 3 from our last slide. 3 pounds per year. So we take the y equals mx plus b. And I'm going to use this point right here. So I'm going to replace y with a 145. M is 3. X is 1992 plus b. So I need to know what 3 times 1992 is. That's 5,976. And then to find my starting value, which this starting value really looks kind of weird because the years are so large. It's not saying that she weighed negative 5,831 to start with. That is how many years ago it would have been if she was gaining only 3 per pound all this time. So our equation of our line is y equals 3x minus 5831. Okay, and this time though we want to know in what year. So we want to find out the y. We want to find out the x value. So we want to find out the x value because we want to know in what year she weighed 202 pounds. I'm sorry for skipping around. Let's get back on it. So in what year will the teacher weigh 202 pounds? So that is actually y. X is the year. So you're going to see why this is a very large number down there. I'm going to add the 5831 to both sides. And every time I get close to the bottom, this happens on this program. Sorry about that. So we're going to get that by itself. So it's going to be 202 plus 5831. So that's going to be 6033 equals 3x. So if I divide that by 3, then in 2011, this teacher would have weighed 202 pounds because they're gaining 3 pounds per year. So those are the steps again for solving these problems. One more. After 30 baseball games, Rod had hit 25 hits. After 100 games, he has 60 hits. What is his average hits per baseball game, and how many games will he have to play to be up to 90 hits? So X, I'm going to have that represent the number of games that he's played. Because depending on the number of games he plays, then that will tell me how many hits he has. So if he played 30 games, that's for this, he had 25 hits. And if he played 100 games, that gave him 60 hits. So we want to find the slope. So the y values are 25 minus 60 over the x values, which are 30 minus 100. So 25 minus 60 is negative 35. And 30 minus 100 is negative 70. And that actually reduces down to 1/2. So our slope is half. So he's about every other game he's getting a hit. Not every game, because that wouldn't be 1/2 then. So we're going to have y equals 1/2 x plus b. Remember, after 30 games, he had 25 hits. And after 100 games, he had 60. So I can pick either one. I'm going to pick this one and plug in the y value and the x value. That's 25. That's 15 plus b. I'm going to take the 15 away, so b equals 10. So what that basically means is that when he started counting, he already had 10 hits. So he's getting a half a hit a game, not really, about 1 hit every 2 games. And he started out with 10. So now we're going to make a prediction of when will he have 90 hits. So remember that hits or the y value. So I'm going to take this, get it by itself, so I'm going to subtract 10. So I'm going to have 80 equals 1/2 x. So I'm going to divide both equations by 1/2. Dividing by 1/2 is the same as multiplying by 2. So 160 games he's going to have to play before he is up to the 80 hit mark. Now you're going to try some of these problems, and I know they're difficult. If you have any trouble, just contact me or contact your face-to-face teacher. Thank you.